Hello everyone. So, we will continue our discussion on perception, cognition, and sensorial modalities in user research methods. And today we will be looking at cognitive load and user interface design and UX research in the context of the same. So, the key learning outcomes of this particular lecture is I will explain how working memory limits and the three load types intrinsic, extraneous, and germane shape interface usability. How will I apply four design techniques: progressive disclosure, chunking, plain language providing context, and matching heuristics, consistency, error prevention, visual design, and signposts to reduce extraneous load. Detect cognitive load bottlenecks in user research using think aloud, task time, and error rate using NASA TLX or SEQ self reports and eye tracking signals. So, the cognitive load theory. So, working memory can hold only 5 to 9 chunks of information temporarily. Cognitive load is the mental effort required to process the information. Overloaded working memory causes forgetting, errors, and confusion. So, there are three types of load. The first one is the intrinsic load, which is about the task complexity. It is the inherent difficulty of the material itself, and the inherent difficulty of the material is unavoidable. Extraneous load is caused due to poor design. So, wasted effort from confusing layouts or distractions. This is purely avoidable. Now comes the germane load, the load because of the learning effort that I have to put. So, the mental work that builds understanding and schemas. This is a desirable load. So, the design techniques to reduce the cognitive load, especially the avoidable ones. Firstly, progressive disclosure. So, what I do over here is hide advanced features until needed, show essentials first, and reveal more options on demand. So, here you can look at the first design example. All the information is upfront, so it is very overwhelming. Whereas in the second example, I have put all of this into under this more options. So once I press more options, more information will be available. So the most important thing is I need to switch on data sync, auto save, and I need to select the sync interval time. So I put them as upfront and visible. Then I can go to more option and put the next set of next most important things, or something which will tell me how much audit logs are to be kept, or how much encryption is to be allowed, what is supposed to be the rate limit, and so on. So, show the essential contents first, then you will provide a way to reveal more, and then you will reveal on demand. So this ensures lower cognitive load, easier to learn, and faster task completion and higher user satisfaction. It also tells your user I can come back to it again and do it the next time. Chunking information. So break large information into meaningful groups. List with 3 to 5 items are easier than 10 plus items. So you can see over here, in this case I have put the customer details. It is so difficult to read through those customer details. However, here I have done a good chunking of that. I have put the name, email address, phone, account and ID and account type in one place, address in another chunk, account details in another chunk, and preferences in another. So this chunking helps you in looking at certain pieces of information as one set. So my brain, rather than having to go through all of them at this point and imagine that, oh, that is too much of cognitive load, now it knows that there are only 4 chunks of information. Within that 4 chunks, I have more set of information. So if I'm only interested in the address, I will look at this chunk. So users can scan, find and process information much faster in this case. Simplify the language. So here look at the language. In order to proceed to the next step within the process, please click on the button located below labeled continue. Now you look at the second option. Click continue to proceed. So that is what is about simplify language. Use plain language, short sentences, active voice, and remove unnecessary words. So it is easier to read, understand and act onto it. So the easier to read, easier to understand, as a result faster to act, and as a result also fewer mistakes which happen. Now coming to provide context. So let's say I tell you to enter your phone number and then the error says invalid phone number. I can also design it in a manner where I say enter 10-digit number, give an example here. This could have also been entered here, so which means once you start typing that disappears, and then I give an information, looks good. Here the chunking also gives you very clear cut information that yeah, it is 10 digits only. So how it helps? It reduces uncertainty, guides users to the right action and builds confidence with timely feedback. Consistency. Same action should always produce the same result. Buttons should look like buttons, consistent terminology, predictable behavior reduces guessing. So let's say I have a particular application and I use 3 different ways of saying save. That is inconsistent. But across the application, for whatever be the screen, I use the same way in which save happens, then that is consistent. So people understand, find it more easily. They do not have to each time read about it. There is a recognition rather than trying to see it, read it, and then act onto it. Similarly, you can see over here, just the my account is in blue, the icon. That is inconsistent because it confuses people. Why is that icon in blue? There is something that needs to be done specifically or that is constantly highlighted. So the consistent way will be having the same kind of color. Different parts of the application, if you change the color of the dustbin icon, again that is confusing. So keep it consistent. Let's say I have these actions over here, edit, remove and view. Whereas you look at these actions, this has all of them have the same icon over here, which helps you in understanding that okay, when I press this, there will be a sub menu which will be opening up, which is literally the case how I am trying to design this. So use this consistent pattern so that people know something will happen next and it is consistent. So it helps in faster task completion, lower cognitive load, better user experience and higher success rates. Then coming to error prevention. So confirm risky actions, prevent invalid input, provide constraints and allow easy recovery. So if you look at the first example, which is about confirm risk action, so delete project, this action cannot be undone, and then you have the delete button. However, a better option is to say delete project, this action cannot be undone, and then you have the option to cancel as well as to delete, because in the previous one you had no longer option to cancel. The only option over there was delete option. Similarly, how to do this invalid input prevention? I say send message and send, whereas so it is confusing. What message am I supposed to send? So let's say this is a chatbot for an e-commerce website and you want to cancel a particular order. So if you had said that okay, this is what you are supposed to send, then there is an idea. So next time when you want them to put an order ID, then you can over there put order ID example so and so. Next time when you want them to put the concern, you can put that concern. So what this prevents is invalid input entry. Then provide constraints. So let's say I have a password column. So I have a certain constraint for a password. So I should make that constraint visible to people. Otherwise, after you have filled up the entire form and then you go and proceed, and it is like change the password and you have to again go back, figure out what is the problem, is something which increases cognitive load and decreases users' experience from the interface. Now coming to allow easy recovery. So let's say file deleted, no undo available. That is not a good idea to have. Whereas if you can do file deleted and undo, which means it is easy to recover. So by mistake, if you reach there, then you can recover the file. So how it helps? Fewer mistakes, stop errors before they happen, less frustration, users feel confident and in control. You are saving time, less need to fix or recover from errors, and better outcomes. So accurate actions lead to successful results. Visual design. So you need to look at the visual hierarchy. So good visual design makes information easy to scan, understand and act on. Use hierarchy, alignment, white space and grouping to reduce this cognitive load. So let's look at the visual hierarchy first. So highlight what matters most. So here if you look at this, nothing is highlighted. So it looks like a lot of effort to go through the details over there. Whereas here I can see I have highlighted, I can see that the order ID is here, shipped is here. So I know the status, I know the date, I know the person to whom it is supposed to go and the total amount and the items. The same information over here was presented without a visual hierarchy, making it feel like a daunting task to interpret what was going on over there. Now alignment. So let's say I have this billing information where I have name, email address, phone number aligned left side, and here there is an alignment to the right side. I have to visually scan through, okay, the name is Alex, email address is so and so, and phone number is so and so. However, if you look at this particular alignment, my eye has to do less work. So in a form with 3 inputs or 5 input points, it is little less important whether you go ahead with this design or this design, but a long form should actually follow this design only. Then coming to the white space. So look at this particular design. So I have email updates, marketing offers and product updates. And look at this particular design. What I have changed is the gap between these two, and because the gap between these two has been modified, you can quickly notice that there is a difference in the readability and how your eyes and brain can quickly scan through everything, read through it and make meaning more easily in the second option. Then coming to grouping. So look at this grouping. So I have name, address, city, email, phone and state. So the state, which is part of the address, again comes down over here. So I might enter the address with the state over there, and then I have to again enter it next. So try to see what groups are made with related items. So the name and the email address are the first contact information. I chunk them together. The address is the next information. I can also put the phone number in the first set because it is part of contact information. But if it is a shipping detail where the phone number is important for shipping purposes, I can also put it into the address column. So when you do this kind of visual design, it helps in faster comprehension, lower cognitive load and better user experience, and also higher task success rate as a result of all the 3 preceding impacts. Now coming to the last one, which is about signposts. So progress indicators show where users are and how much work remains. Feedback confirms action and status messages explain what's happening over there. So let's look at the progress indicator first. So over here you can see that I have some form of progress indicator which says step 2 of 4. However, in this case I have to go through 3 chunks of information: create account, then 2, and then step 2 of 4. Whereas in this particular context, I am saying that, okay, create account, and then I have these 4 steps I am already done at the 2 step. This particular piece of information is redundant and you can completely avoid having that. But in case you have a lot of such steps to be done, which is generally avoidable, but sometimes it might not be, then in that case you can put that down over here as well, because everything is not fitting in. When I have an extremely long line, this is again shows, oh my god, I have to put so much effort. Then comes the system status. So uploading file, when I cannot see what is happening. Even if this whole thing was going green, 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 I still only have a visual idea that how much I have reached. So you cannot see a difference between 75% and 76%. But here, just by adding that 75% complete to that, I can also see the difference between 75% complete and 76% complete. Then coming to error. So unable to save changes. That's how you are giving the feedback. So the confirm action with feedback is, okay, we were unable to save. However, people do not get much out of it. Either you should have that with a message which says that why you were not able to save it, only then people are able to act upon it, or when you have like success, your changes have been saved, which is like anyways the best desired result. Then coming to how to go to the next step. So say for example it says payment is successful. Now, okay, payment is successful, but what is the most logical task that you want to do? I would like to view a receipt, or I would like to continue my shopping. So this second option is a much better design, where I have this option where after payment successful information is given, I can lead them to the next step, which might be their choice of viewing the receipt or continuing with the shopping process. So why it matters? Faster task completion, again lower cognitive load, better user experience, and as a result higher success rate. So now coming to this paradox of choice. So we discussed about this cognitive load in terms of design on the screen. Now this paradox of choice is valid across many other domains. Even in when you are having marketing, how many product options will you have? How many feature options will you have? So more options, many versus few, leads to a harder decision making, less satisfaction, and decision paralysis. So, squads demonstrated that 3 to 5 options are optimal for decision satisfaction. So, what I mean over here is, let's say you give your customer an option to select from so many different models of coffee machine. For your company, it is about changing one particular part or one particular color, and then create a next version. However, think from the user's perspective. It is so difficult for them to make a choice, and it leads to this decision paralysis. They are not sure whether I should go with this model or I should go with this model. Of course, in this case, one of the determinant factor becomes, okay, $349 and $329. So then I have to go through the feature list. Is this $29 extra worth the feature that I am going for? Would I need it in future, so that I should still invest into that thing? So it is too many choices increases cognitive load and decision difficulty, less satisfaction, and design paralysis. So more isn't always better. It makes choosing harder and satisfaction lower. So here you see I have given you only 3 different options. It is easier also because the differences are on the $100 scale. So I clearly should know whether I am a person who needs the features of a $449 or a $549 or a $649 model. So the decision is easier because there are fewer choices. That results into higher satisfaction and more confidence when I am making a particular choice. So the solution over here is limit the product selection, form fields, and menu items. Curate options thoughtfully. Provide default recommended options. Reduce cognitive burden of choosing between many equally valid alternatives. Now coming to the cognitive load, how it is to be thought of when you are trying to do user research. So every task that you give carries a particular load on the person with whom you are doing user research. So a researcher's task difficulty includes the mental effort of the task itself, not only the interface that they have to deal with it. So asking a participant to compare 3 plans on price, coverage, and fees in their head is a difficult thing to do. So think whether they will be able to do it, whether you should provide some kind of support so that they are able to do it more easily. Then comes overload distorts data. So overloaded participants make errors and give shallow answers. You measure the study and not the design. So for example, they will click randomly to finish it. So let's say you have a questionnaire which has 30 questions or 50 questions. It is too much of data overload for them. So then they will start randomly clicking Likert scales or clicking yes, no, or if there are answers to be written down, they will be just writing some keywords, some meaningless words, or just gibberish words. They can also say that, okay, click randomly to finish, then say it was fine in the post-task survey. So that is a problem. So design your survey instrument or any kind of user research considering that overload should not happen. Now, load is a finding, visible struggle. So let's say if I am trying to hunch into this particular screen, try to see okay, what is happening, where it is happening, then that is a problem. So try to identify visible struggle, hesitation, and rereading signal. They all signal extraneous load in the product. So which means load due to the how the product has been designed. So a user rereads the checkout summary 3 times before clicking pay, which means that there is a lack of confidence. Why there is a lack of confidence? Not because the user is not confident, because your design is not able to deliver to them the confidence that they have done everything the right way. So maybe you have not chunked the information properly. That's why they are reading through it multiple times so that they can ensure that all the details are there. In case you have chunked the information, so let's say I'm trying to check out a flight ticket. If the information was properly chunked, which tells me easily, okay, this is the time, these are the passengers, then I would have gone through the checkout process much faster. Working memory is limited. So Miller says that 7 plus minus 2 is the limit, and it applies to participants following your instructions too. So when you are trying to give them an instruction to do certain task, a 9-step task prompt, your participants are not going to remember. So the steps should be in between 4 and 7, fewer the merrier, because then the chances of remembering is much higher. Now considering the cognitive load in the practice, in the research tactics. So design lean task, 1 goal per task, short plain language instructions should be given, avoid stacking subtasks. So let's say find a vegetarian recipe under 30 minutes is a good instruction, and not like find one vegetarian recipe which can be cooked under 30 minutes, then save it and then share it also. So the second one is a long piece of information, and you should not try to give it all in one go. Try to give it in 3 different steps. So first step is find the recipe with certain specifications, and then save it and then share it. Watch for strain. Note pauses, size, scrolling back, and wait what kind of statements or expressions as the moments as load indicators. So a user hovers over the same button for 8 seconds. So I'm hovering over the for 8 seconds, which means there is overload and the user is somehow trying to drain them of the overload, and they still want to show you that they are doing some work and they are just hovering around before doing the actual click. Limit the session length. Fatigue inflates load. Keep sessions short and build in breaks. So if you are conducting usability sessions or interviews, focus group discussions, sessions when they are planned at about 45 minutes in one go, it is a good duration, and after every 45 minutes add a 5-minute break after the third task is done. Separate the task versus the UI load. Distinguish difficulty caused by your task design from difficulty caused by the product. So if all 5 users fail step 2, is your prompt unclear or is the UI confusing? That's what your investigation has to be around. Now coming spotting the cognitive load bottlenecks when you are doing this user research. So you also need to match the method that you will be using for user research to the kind of load you want to detect. So there is a method called Think Aloud protocol, which we will be discussing in later weeks in detail. This method can be used when, so in this particular method, when somebody is using a particular interface or doing a particular task, they are asked to verbalize everything that is going on in their mind. So ask users to verbalize throughout as they work, hesitations, rereading, and what does this mean, reveal load. Example, I'm not sure if save means save draft or publish. So if your user says that, then it implies that that is a confusion and you need to work on to that. Then comes the task time plus error rate. So let's say I identify step 3 takes 2x longer and 40% of the users misclick. So that is about the measurement of the how much time that particular task takes and how much error happens. So track completion time and slip rate per step. Spikes which localize on certain aspect of the flow, that implies that that particular flow has a very high cognitive load and you should redesign it to reduce the cognitive load. Then comes the NASA TLX or SEQ. These are standardized self-report scales and quantify perceived workload across mental, temporal and effort dimensions. So the SEQ score will, for example, drop from 6.4 to 3.8 on a multi-step form. Then you can do proper chunking and progressive disclosure and see if the SEQ score goes up or not. Eye tracking and pupillometry. So when I am trying to do think aloud protocol or interviews or even NASA TLX and SEQ, because these are self reports and so think aloud is happening in real time. The NASA TLX SEQ interviews or contextual inquiry, they can happen post the activity also. Contextual inquiry can also happen during the activity. Now, the problem is human beings always choose what they want to verbalize, and they will not, when it is like concurrent with the task and they are verbalizing, that time also they are choosing what they would want to verbalize. And when it is a post task completion feedback giving or interview answering, it is also the recall factor is added to the whole picture. So there is this problem of biases or related to recall bias, or people do not want to verbalize actually what was actually in their head because of whatever reason it might be. So there comes the benefit of having eye tracking and pupillometry. So fixation patterns, so whether I look too much on this part of the screen or on this part of the screen, or my gaze just completely kept on moving all over the place. How the scan paths happen, how the pupil dilation exposed visual search effort and overload moments. So eye tracking and this pupillometry can be a very good tool because it can track subconscious level information and actually in real time how people are dealing with a particular interface and figuring it out. So users can scan the dashboard 8x before finding the export button. This I can figure out exactly because I have this entire eye movement data. So the best interface is the one that disappears, and users should focus on their task, not on operating the interface. That's why I am trying to do user-centered design, and user research method needs to figure this out appropriately. So the key takeaways from this particular lecture are: the mind has 3 load levels. The intrinsic load is inherent to a task and it is unavoidable. The extraneous load comes from the design of the interface, the design levers that I am using, and it is avoidable. I can redesign to reduce that load. Germane load builds because I need to learn something, I need to understand something. Again, it is unavoidable. In many cases, it is desirable also because people love that right kind of challenge which will help them getting that satisfaction of learning something new. Designed to cut extraneous load. So use progressive disclosure, chunking, plain language and clear context. Apply consistency, error prevention, visual design and signposts. Load distorts the research data. So overloaded participants, because the design of your research is done in a manner that the participant gets overloaded. So these participants will slip through. They will click randomly, give shallow feedback, separate task design load from the product load when interpreting results. So say for example, you had a 20-point questionnaire to be answered. That is a overload situation. So your product load might not be that very high, but this overload of research becomes very high. So you need to separate them out, whether the load was because of they were supposed to interact with the product, learn this thing, use this thing, or because the way your research has been designed. Measure the load with mixed methods. So you can combine think aloud, task time plus error rate, NASA TLX or SEQ, and when available, eye tracking to locate the high load step. So this combination methods can give you way much more richer data and better data about the cognitive load. So that brings us to the end of this particular lecture. Here are some of the references for you to go through. I will see you next when we will be discussing about attention, memory and information retention. See you then.